All right, our last video had to do with transforming exponential functions, more specifically finding the x and y intercept for exponential functions. Today we're going to look at solving exponential equations. Okay, we did solve exponential equations when we did the intercepts, so this shouldn't be too much of an extension from that. Before I get into that, I'd just like to review some exponent laws with you that will be helpful. And I'm also going to show you a page where I wrote down a bunch of powers of 2, 3, 4, and 5 specifically. Be helpful to kind of have a look at those. It makes doing these questions a little bit easier if you can kind of have an idea of what the powers of 2 and 3 and 4 and 5. Not necessary, however. Okay, so start with some exponent laws. First question, our first example here is x squared times x cubed. Just want to remember that when you multiply powers with the same base, you write your base down, x, and we add our exponents. So x to the power of 2 times x to the power of 3 becomes x to the 2 plus 3, or x to the 5th. Okay, pretty simple. When you divide powers with the same base, you subtract the exponents. So this would become x is my base. Write your base down again. Now subtract the exponents. 2 minus 1/3. That's like saying 6/3. 2 over 1 would be 6 over 3 minus 1 over 3. It's going to leave me with x to the power of 5 over 3. Multiplying powers, you add the exponents. Dividing powers with the same base, you subtract the exponents. Raising a power to a power, you multiply the exponents. So write your base down, x, and then multiply the exponents. Now, if you had to write that or simplify that further, sometimes you don't want to see negative exponents. You could write that as 1 over x to the 10th. Okay, take the reciprocal of the base and make your exponent positive, which would be 1 to the 10th, 1 over x to the 10th. Okay, remember when you raise a fraction to a power, the numerator gets raised to that power, so 1 to the 10th would just be 1, and the denominator also gets raised to that power. Last couple of things, we're going to look at something that we looked at in grade 10, I believe. When you have radicals, remember the square root of x is like saying x raised to the power of 1/2. Okay, the cube root of x is like saying x raised to the power of 1/3. Right, the fifth root of x, x to the 1/5. And this here, the cube root of x squared, that actually becomes x to the 2/3. This last one, inside the brackets, if I did that first, that would be x to the 1/5. And then it's all raised to the 3rd. Now remember our rule up above, when you raise a power to a power, this would become x to the 1/5 times 3, which would be 3/5. Okay, that's just a quick review of some exponent laws that you've learned previously. All right. Here are some powers of 2, powers of 3, powers of 4, powers of 5. The reason I show you these because when we get into solving exponential equations, what we want to do is get a common base. All right, we want to break it down to a spot or get it to a spot where we have a single power on the left and a single power on the right. And then we want to convert them or get them to have the same base. And I'll show you what I mean by that in a couple of minutes. All right, first, let's start writing these as powers of 3. All right. Not a whole lot of work needs to be shown for this. 27, a lot of people know that that's just 3 to the power of 3. 3 times 3 is 9, times 3 is 27. 9 squared, that could be written as 81, right? But I want to write this as a power of 3. Well, 81 is 3 to the power of 4. Now, I want to show you where they come from. 27, 3 to the 3rd, 81, 3 to the 4th. That's why I suggested knowing your powers of 3. Look, 3 to the 3rd is 27, 3 to the 4th is 81. I also said it's not necessary to memorize those because we know our change of base formula. If I want to change a base of 27 to a base of 3, I can do the log of 27 divided by the log of 3. I have a base of 27. That's what I'm starting with. I want a base of 3. It gives me an answer of 3. That means 3 raised to the power of 3 equals 27. Here I could go the log of 81 is what I have, divided by the log of 3. That equals 4. That means 3 raised to the power of 4 equals 81. Again, you could use natural logarithms instead of common logarithms. Don't have to show this, all right? Pretty simple questions. Okay, 27 to the 1/3, right? There's a little more to this, but 27 to the 1/3, that just means the cubed root of 27. The cubed root of 27, this whole thing right here, is going to simplify to a 3. It's multiplied by, this would be 81 to the 1/3 times 2. Now I'm not going to do the cubed root of 81 because that's not a nice whole number. Okay? I don't know exactly what the cubed root of 81 is. I know it's a little bigger than 4, a little less than 5, something between 4 and 5, but we're not going to get into guessing. I'm going to use my exponent laws. All right? The cubed root of 81 is like saying 81 to the power of 1/3. That's all raised to the power of 2. The rule is when you raise a power to a power, you multiply the exponents. So 2 times 1/3 would give you 2/3. So this would become 81 to the 2/3. All right. I'm going to change 81 to a base of 3. That 2/3 isn't going anywhere. 81 is really 3 to the 4th. If you're not sure where that's coming from, look no further than question B. All right, the log of 81 divided by the log of 3 is 4. Or if you know that 3 times 3 times 3 times 3 is 81, even better. Then I'm going to multiply here. This 3 just keeps following down. This now becomes 3. 4 times 2 is 8. Over 3. Now I have 3 to the, well, what's the rule here? What am I doing to this 3 and this 3 to the 8/3? I'm multiplying them. And what's the rule when you multiply powers with the same base? Okay, they both have a base of 3 in this case. Well, you write your base down, and then you add the exponents. So it's going to be something plus 8/3. Well, what is the exponent on this 3? If it's not written, it's understood to be a 1. So I'm going to go 3 to the power of, okay, the video froze there. My smart notebook froze for a second. So back at this, 3 to the 1 plus 8/3. That's 3/3 plus 8/3. So 1 over 1 would be 3 over 3 plus 8 over 3 gives me 3 to the 11/3. Not a nice exponent, but that's the answer nonetheless. It wanted me to write all of these expressions with a power of 3. And there they are. Okay. Next, we're going to look at actually solving an equation. All right. So remember, we got to do this, we need to know our powers. All right, or we got to get these written with a common base. And we also have to know our exponent laws. If you want to give these a try on your own right now, go ahead and do that. You can pause the video and work them out on your own and then check the answers in a moment. All right, first example. We have 4 to the power of x plus 2 equals 64 to the power of x. common base I'm going to use in this case is 4. All right. I could use a base of 2, but it's easier to use a base of 4 because I don't have to change anything on the left-hand side. It already has a base of 4. 64. All right, 64 is 4 to the power of 3. Again, if you're not sure how I'm getting that, remember it's the log of 64 divided by the log of 4. It equals 3. Don't forget to write 4 to the third. You can't just write a 3 here. 64 doesn't become a 3. It's 4 to the third. Or if you know your powers, if I scroll back here, look at 64 is 4 to the power of 3. Now, use your exponent laws. 4 to the power of x plus 2 equals, when you raise a power to a power, I'm going to multiply these exponents. Write my base down, 3 times x, 3x. Now I've got it to the point where I have a single base, single power on the left, and a single power on the right. I can drop the base, like we in a club. My wife likes that one. Okay. X plus 2 equals 3x. Now I'm just simply solving for x. So I can subtract x from both sides. I would get 2 equals 2x. Divide both sides by 2. And I will get x equals 1, or 1 equals x. Now, what you want to make sure you do in the end, or once you get your answer here, is you want to test your answer. What I mean by that is make sure that x equals 1 is a solution. So I'm going to write down my original question. I'm going to replace the x's with 1's. So this would become 1 plus 2, that's 3. This is 64 to the first, or 64. All right, 4 cubed is 64. 64 to the first equals 64. That means x equals 1 is a solution. Don't forget to check your answers. Right? They don't always work as sometimes you get an extraneous solution or something that is not a solution. All right, over here. A lot of people, when they see this one, they automatically want to use a base of 4. It's not wrong to use a base of 4. It's just when you go to change 8 to the power of 4, you end up getting a decimal here. All right. I would choose a base of 2. Why? Because both 4 and 8 can be expressed with a base of 2. What I mean by that is 4 is really 2 squared to the power of 2x, and 8 is really 2 cubed to the power of 2x minus 3. Notice these exponents didn't change. All I did was change the 4 to a 2 squared. 2 squared is 4. And I changed the 8 to a 2 cubed. 2 cubed is 8. How do I do that? The log of 4 divided by the log of 2. I should say, or finish what I was writing up here. A base of 2 is what I used. A log of 8 divided by the log of 2 gives me 3. All right. Move on to your exponent laws. This would become 2 to the power of 4x. When you raise a power to a power, multiply the exponents together. I'm going to do the same on this side. Just remember that you're multiplying the 3 by the 2x and the 3 by the negative 3. So this actually becomes 2 to the power of 6x minus 9. Drop the base. 4x equals 6x minus 9. Okay. 9 equals 2x. So I brought this guy over here, and I brought this guy over here. The negative 9 became a positive 9. 6x minus 4x became 2x. Divide both sides by 2. And x is equal to 4.5 or 9 over 2. it doesn't matter. I don't care if you use a decimal or if you leave it as a fraction. All right. I would suggest using fractions. Sorry, I would suggest using fractions because that's typically what the back of the book would use. But if it's like something over 2, we're just talking halves, or something over 4, it's quarters. Decimals are cool with me. Right? It'll depend on your teacher or your prof next year. I don't get too bent out of shape over it though. So I want to test my answer. 4 to the power of 2x equals 8 to the power of 3x, 2x minus 3. 2x minus 3. So as I said, if you want to use decimals, this becomes 2 times 4.5. This becomes 8, and then 2 times 4.5 minus 3. We've got 4 to the 9th equal to 8 to the 9th minus 3. So 4 to the 9th equals 8 to the 6th. 4 to the 9th is 262,144, and then we'll check 8 to the exponent 6. The mem shows same thing, 144. That means x equals 9 over 2 is a solution, or x equals 4.5 is a solution. Okay, so we'll have a look at the full screen. Okay, writing expressions with a common base, or in this case a power of 3. Exponent laws, powers, and solving exponential equations. Here's an example you can try on your own. I will pause the video, or sorry, you can pause the video right now. Try that question on your own. I encourage you to do it. All right, a base, I'll give you a hint. The base that you could use here, 27, 1/9, and 81, can all be expressed with a base of 3. So pause the video, give that a run. Here is what you should get for your final answer. Negative 11.5. Good luck.